Hello, hello. Hi. All right. So today I'm going to solve more Advent of Code because I have missed a couple days here. Seems like the numbers are mixed up. They're going from top to bottom now instead of going from bottom to top. Okay, sure. So we stopped on the day 13. This was the last one. Let's go ahead and start the day 14 now. Day 14. Parabolic reflector dish. You reached the place where all of the mirrors were pointing, a massive parabolic reflector dish attached to the side of another large mountain. The dish is made of many small mirrors, but while the mirrors themselves are roughly in the shape of a parabolic reflector dish, each individual mirror seems to be pointing in slightly the wrong direction. If the dish is meant to focus light, all it's doing right now is sending it in a vague direction. This system might be what provides the energy for the lava. If you focus the reflector dish, maybe you can go where it's pointing and use the light to fix the lava production. Upon closer inspection, the individual mirrors each appear to be connected via the elaborate system of ropes and pulleys to a large metal platform below the dish. The platform is covered in large rocks of various shapes. Depending on their position, the weight of the rocks deforms the platform, and the shape of the platform controls which ropes move and ultimately focus the dish. In short, if you move the rocks, you can focus the dish. Yo, Code Monkey, hi. Thanks for the sub. 9 months. Nice. The platform even has a control panel on the side that lets you tilt it in one of 4 directions. The rounded rocks will roll when the platform is tilted, while the cube-shaped rocks will stay in place. You know the positions of all the empty spaces and rocks. For example, this. Start by tilting the lever so that all of the rocks will slide north as far as they will go. You notice that the support beams along the north side of the platform are damaged. To ensure the platform doesn't collapse, you should calculate the total load on the north support beams. The amount of load caused by a single rock is equal to the number of rows from the rock to the south edge of the platform, including the row the rock is on. Cube-shaped rocks don't contribute to the load, so the amount of load caused by each rock in each row is as follows. Alright. So the lowest, so we make all the round rocks go up. The closer they are to the top, the bigger the load. The total load is the sum of the load caused by all the rounded rocks. So in this example, the load is 136. Wait, is it? Is it? Start by changing the levels so all the rock will slide north as far as they will go. Okay, so we calculate this after they are up as far as they can go, and after that we calculate it. Right. Right. Okay. This sounds easy. This is the first part though, obviously. Alright. Let's see if I remember how to do this. Advent of Code 2023. We have a bunch of things here. Can I do instead? Can I do instead over here? New folder, day 14. New main rs. Is this working? Cargo run bin day 14. Yes. This is going to work. I'm just wondering if I put my input over there. Instead. And then for part 1 and part 2, I'll also do something. Part 2 is std args contains the part 2. What do I have here? I have a string. Oh, okay. Well, I mean, I'm not exactly sure what's wrong here with the itertools. Can I do like any arg? Is this? Okay. I can do that instead. Okay, I'm just going to like do it a little differently here. I'll try a different approach. So instead of I'm going to take this example here, and I'm going to make this all in this folder. So example is this, and the actual input is this. A14 input. All right. Okay, let me do this. Input is I can also do this. If I try to run an example, then it's example. Why is my input not a regular file, but something else here? It was identified as Dart language. Why? Okay. Anyway, here's what I'm going to do. I'm going to convert the input into a double array of tile, and then I have the tile, which is either round rock or box rock, right? Or empty. Okay, so it's going to be input lines. Input lines, and for every line, I take line chars, I map those, and I see if it's an O, then it's a round rock. If it's a hash, then it's a box rock or a square rock. If it's dot, then it's empty tile. Otherwise, it should be unreachable. Okay, so this is me reading the input, and then I run the example like this. Okay. So I have the input, and the next thing that I'm going to do is calculate the thing. So the way I'm going to solve this one is I'm going to go from the top to the bottom. and I'm going to, for every column, do it separately, right? So I go from the top to the bottom, and remember the next row the circle rock is going to roll to, right? And if I see a circle rock, then I make it go there. If I see a square rock, then I update the next place the round rock is going towards, right? Yeah, something like this. So for column in 0 to input 0 length, which is the number of columns, right? Over here, I'm going to, like I said, remember the last like obstacle, basically, right? Or not the last obstacle, right? Last place where the round rock is going to go, basically, right? So origin is going to go towards the row number 0, right? To row number 0, and then I go for row in 0 to input length, right? I'm going to match on the input at the row, at the column. So if it's empty, then I do nothing. If it's box, then I say that the last place where I'm going to get to is the current row plus 1. And if it is the round rock, then we increase the last place by 1. But also we make sure that this round rock goes into the last place, right? So I add to the answer like, what was it called? The load caused by that rock when it goes into its place, basically, right? The load. So load for this rock is going to be last place. Is going to be input length minus last place. And this is going to be added to the answer. Okay, so I have found the answer to be 136. And the answer is indeed 136. So let's run it on not the example by doing that. And this is our actual answer. Submit. Correct. Continue part 2. Parabolic reflector dish deforms, but not in a way that focuses the beam. To do that, you will need to move the rocks to the edges of the platform. Firstly, a button on the side of the control panel labeled spin cycle attempts to do just that. Each cycle tilts the platform 4 tiles so that the rounded rocks roll north, then west, then south, then east. After each tilt, the rounded rocks roll as far as they can before the platform tilts to the next direction. After one cycle, the platform will have finished. Hold on. Each cycle to the platform 4 times so that the rounded rocks roll north. So we go up, then left, then down, then right. Here's what happens after each of the first few cycles. Yes, so it seems like after the second cycle and after the third cycle, no, it's not the same actually. This probably should work if you leave it running long enough, but you are still worried about the north support beams. To make sure they will survive for a while, you need to calculate the total load of the north support beam after 1 billion cycles. All right. Does the event of code only run during December? I think so. I'm not sure. But I'm pretty sure that it is, yes. Like December 1 to December 25. You can solve it any day possible. You don't need to solve it when it's happening though. You can go and like you can go to the website and you can go to the previous year's events, I think 2020, 2015, like for example over here. Go click over here and try and solve this one if you want. I only did it once in 2021. I got 12 stars. This time I'm running a little further. Sniper Elite. Hello, hello. Run the spin cycle for 1 billion cycles. Afterward, what's the total load on the north support beams? Alright, well, it seems like it's not just me doing the cycles manually. So, what is it going to be? Are we going to go in a loop eventually? I think that this should be stuck in a loop eventually, right? Mm-hmm. It's like a good brain exercise. Yeah, pretty nice. Well, I can just like start writing the thing, assuming we are going to be stuck in a loop, and then once I detect the loop, we're just going to stop. Hello, Vess. Or I can think about it for a little bit more. I heard that the advent of code. So this is day 14, and it's going to get harder now. Hi. Hi. Okay, well, I don't know how to prove that it's going to, like, be stuck in a loop. So, like, this cycle is not is going to, like, stay the same. It is my theory. It tells you how many cycles to run. Yes, exactly. But what I'm saying is that after a certain amount of time, the cycle is going to, like, it's going to stay the same, the picture, after each cycle. Is my theory right now. So we are not actually going to need to run 1 billion cycles, because that's going to run for a long time. Let me try. If part 2, otherwise it's a different thing. So this was part 1, and now for part 2 I'm going to do this cycle function, right? Which is going to convert this map into a new one, right? Let me make sure that these guys I can hash colon copy debug, sure. Okay. Cycle. So cycle, I'm going to do this. I'm going to do this here. I'm going to do 4 times. 4 times. I'm going to say that map is go up of the map, which is like we did in part 1 basically. And then we do map is rotate clockwise of the map. And this is what I'm going to do. So I need those 2 functions. This thing that I was doing before is go up. I'm just going to do it a little bit differently, right? So instead of adding something to the answer, instead of calculating the load, I'm just going to say that result at this column at the last place is going to be equal to tile round rock. So I'm placing the round rock into the result correctly when I'm going up. I'm going to start with the result being the thing of the same size, but completely empty. Right, and then I'm just going to fill it up by box rock is also going to be like placed there. Result row column. Like this. Or hold on, I can just do instead map clone, I think. And instead of doing this, I'm just going to basically move the round rock from this current place. So this is going to become empty. But where the rock is rolling is going to become the round rock. That's like better way of doing it. Which means that I can even like not even I can do this in place. I can do this in place so that I spend less time cloning stuff. Right? Okay, and then I do the rotation clockwise of the map. So this is going to be what? I'm just going to say that we basically like swap rows and columns or something here, right? I do 0 to map length, which is like the number of columns. I map those. This is the column original, and then I do 0 to map length, which is the number of rows. So over here, I'm going to say map row column, right? Is that right? No, I don't think that is right. The rows need to go from the bottom to the top, because the bottom row is going to become the leftmost row. So this needs to be reversed, basically. Okay, So that's done. We can, so this is our cycle, right? I'm going to calculate the cycles. I guess I can just make this here. And then I calculate, then I have another function which calculates the load of the map. Right? What? Whatever. Okay. So if it is part 1, then we just calculate the load of the input and print it out. If it's part 2, then I do 1 billion cycles. I'm going to do new map is a cycle of the map. Originally map is going to be equal to the input, right? And then over here I say that if new map is equal to the map, then I'm just going to break, because like nothing is going to happen, right? Nothing is going to happen. So, and then I calculate the load of the map after 1 billion cycles, right? Let's see. So let's run this on the example. But we do part 2, right? It seems like it still is going to run for a long time. What if I do this in release mode though? Maybe I implemented this wrong though. So the map is always different. The example is very small. How about we how about we do this then? Okay, let's see what's happening here. Let's see what's happening here. It actually is different, but maybe we are getting in a loop. So instead of like cycling, and after the cycle the map is still the same. Let me just make sure. So let's see what actually is changing over here, for example, right? This goes over there somewhere, right? So we first go up, then then we go left, and go down, then go right. Yeah, yeah. Actually, yes. This makes sense. Think. I'm not sure. Doing an entire cycle in my head is not very easy. All right. But let's see. Let's see if I have actually been in a place already, right? So this is going to be visited is going to be hash map new. So this is going to be the cycle index, right? And I'm just going to say that map is cycle the map, right? And then I do visited insert map clone cycle index. But if it was there before, previous index, then we break through, then we break, right? This should be mutable. So over here, if I have been there previously, then let me panic for now. Let me just make sure that I'm getting there. I am. Okay, I am getting there. All right, pretty fast too. What about not the example? Hold on, something is wrong here. Why am I not panicking anymore? Oh, I said it to break. I said it to break. Okay, I'm just stupid. All right. So as you can see in the actual input, it also happens pretty quickly. Maybe it can be proven that it will happen actually. But yeah, so we basically come back to the situation where we have been before, right? So we are going to be stuck in a loop basically. It's like the other advent of code problem where we are also being in a loop. Or was it not the advent of code? No. It was like some lead code that Arya sent us. All right. So we have been in a previous index before, and I know that the cycle length is going to be basically the current cycle index minus the previous index, right? So this is how many do we need to get, right? Cycles. Let's see. So this is how many cycles we need to do. This is the cycle length. So I need to know how many more do I need to do, right? How many more do I need to do? So the remaining cycles that I actually have to do is cycles minus cycle index, and we take this by the module of the cycle length, right? Because we can basically, big steps of the cycle length are going to do nothing. So this is the remaining cycles that I actually have to do. And I can just do this manually here, right? And I can just do this manually here to the remaining cycles. Whatever. And then we'll calculate the load and print out the answer. Let me check on the example. I found the 100 and 0 and 3, which is the wrong one. Is this the... Is this the wrong thing here? This is how many cycles are actually left to do, right? No. So if I was hitting this at in the very end, it's like something like -1 here, I think. Hold on, let me just check this. No, last one. It's 64. Hold on, something is wrong here. What's my cycle length anyway? It's 7. That doesn't help me to understand what I did wrong here. There might be a bug like over there somewhere, but I don't think so. Let me make sure. I will print this out, right? And let's see. So this is the example, and the example is that. Okay, so after one cycle, I get a situation like this. It looks correct. Then after 2 cycles, it looks like this. Looks correct. After 3 cycles, yeah, I don't think there is a bug in this. Yeah, this looks okay. So then I go back to this situation, which has been in the position 3. We find the loop, which is 7. Okay, I just have a problem with my math somewhere over here. If I have been to the place before, then I'm going back to the same place after the cycle length, right? More steps. If it's the previous, then the cycle is 1, yes. So this is the actual remaining cycles that I have to do is cycles minus the current cycle index. Minus 1, because like well, no. Hold on. I want to find after one cycle. This is over here is in the beginning, before I cycled. So I will need to do that one more. So yeah, if I am like in this 0, yeah. Can I calculate the cycle length here? And this is the remaining cycles. And just cycle it like this. In the above example, after 1 billion cycles, the total load on the north support beams is 64. So what exactly is 64? Calculate load. Do I even have 64 anywhere? I don't have 64 like anywhere though. So like the question is, where did they get the 64 then from? The total load of the north support beam after 1 billion cycles. The total load on the north beam support is 64. How do they get 64 if none of these things give me 64? Am I calculating this wrong? The load? I don't think so, right? Oh, I calculate the load wrong here. I see. Okay. I calculate the load. This is like from part 1 of me solving the event of code, so it's not actually the load, it's the load after I move everything north, basically. Yeah, so we just do for row in 0 map length row index and row app iterate enumerate for column in row, and then a flat tile round rock is column, then answer plus equal the load, which is map length minus row index, right? And then I return answer like this. So like the part 1 is not just calculating the load, but I calculate the load of going up of the input. That's the actual thing of the part 1. Yes. For the part 2 it's 64. Okay, amazing. Okay, finally. I was not doing anything wrong. I will remove the print debugging here, and let's just run the part 2. So here's my answer. Okay, nice. I wonder how can you like prove it that it's going to start like running in cycles. It's like the intuition, but you can actually like prove it somehow, I guess. But whatever. We have I have like 4 more days to solve. Day 15. Okay, so this is day 14. Yeah, I like this way of doing things. So day 15, once again, main, um, main. I'm just going to do it the same way in the beginning here, right? And then I need example. Let me read this first though. Lens library. The newly focused parabolic reflector dish is sending all of the collected light to a point on the side of yet another mountain, the largest mountain on Lava Island. As you approach the mountain, you find that the light is being collected by the wall of a large facility embedded in the mountainside. You find a door under a large sign that says Lava Production Facility, and next to the smaller sign that says Danger. Personal protective equipment requires beyond personal protective equipment required beyond this point. As you step inside, you're immediately greeted by a somewhat panicked reindeer wearing goggles and a loose-fitting hard hat. The reindeer leads you to a shelf of goggles and hard hats. You quickly find some that fit, and then further into the facility. At one point, you pass a button with a faint snout mark and the label "Push for Help." No wonder you were loaded into that trebuchet so quickly. You pass through a final set of doors surrounded with even more warning signs and into what must be the room that collects all of the light from the outside. As you admire the large assortment of lenses available to further focus the light, the reindeer brings you a book titled Initialization Manual. Hello, the book cheerfully begins, apparently unaware of the concerned reindeer reading over your shoulder. This procedure will let you bring the lava production facility online, all without burning or melting anything unintended. Before you begin, please be prepared to use the Holiday ASCII string Alper algorithm, Appendix 1A. You turn to Appendix 1A. The reindeer leans closer with interest. The hash algorithm is a way to turn any string of characters into a single number in the range 0 to 255. To run the hash algorithm on a string, start with a current value of 0, then for each character, starting from the beginning, determine the ASCII code of the current character of the string, increase the current value by the ASCII code you just determined, set the current value to itself multiplied by 17, and then set the value to the remainder, dividing itself by 256. After following these steps for each character in the string in order, the current value is the output of the hash algorithm. So to find the result of running the hash algorithm of the string hash, you do this. The result of running hash algorithm of the string hash is 52. The initialization sequence, your puzzle input, is a comma-separated list of steps to start the lava production facility. Ignore new line characters when parsing the initialization sequence. To verify that your hash algorithm is working, the book offers the sum of the result of running the hash algorithm on each step in the initialization sequence. For example, we'll have a comma-separated list. Initialization sequence specifies 11 individual steps. The result of running the hash algorithm on each of the steps is as follows. Okay. Understood. In this example, the sum of these results is this. Unfortunately, the reindeer has stolen the page containing the expected verification number and is currently running around the facility with it excitedly.
Hello there.
Hello, Nerdsol. Run the hash algorithm on each step in the initialization sequence. What is the sum of the results? All right. Okay. So this is my example here. And then this is my actual input. No, this is wrong. Hello there. Tulkas Code, hello. You know what? What? What do I know? They say ignore the new lines, but there is only one line here. You've been making a small text-based game in Scala. Amazing. You like Scala now? This over here is a makefile, according to VS Code. Scala is not that great, you really like monads? Scala has the algebraic effect systems too. Not in the language though, I think in the libraries. Can you minimize the size of icons in activity bar for VS Code? Trying to switch for new Vim, but the UI is kind of annoying. Me, your mom. These icons? I don't know. It never. I can hide it. You can do, for example, the Zen mode. You can do the Zen mode, Control KZ, and then all I have is this. But maybe there is like another plugin that like just hides that part. It's not how fmap works. I like these icons. I mean, maybe there is like too much. All the icons that I actually use is the Explorer and the source. You can also move them. Now that I think about it, you can move it like this, because those are the only panels that I'm actually using. This is my new amazing setup. All right. You can also hide them. You can also hide them like search. I'm not really using search. I can do Control Shift F to like open the search automatically, but it's going to be hidden. GitHub Actions, bookmarks. I'm not using those. Git Lens, run and debug. I'm not never running and debugging. Extensions. I can just do this. Can I like hide it completely? I can hide it completely, but yeah, I don't know. Come on, man, you can't be doing this shit. Factory must grow. I need to come. I will play more Factorial, but I will need to do this first. All right, I need to solve the advent of code, and then we can play Factorial a little more. Not today, though, it seems. I have a bunch of advent of code to do. So when is Linksider being released? Yeah, all done. All done. Let me do one thing at a time. One thing at a time. There's one Linksider at a time. Hold on. I'm doing advent of code right now. Okay, so I'm going to take part one. No, not part one. I'm going to take input. I'm going to split it using the commas, and then I'm going to map those into the hash function, right? And then take the sum of those, and this is my answer. Supercuber, alcohol, decode. Is that a good way to run to the code though? Let's see. So we have a U8, 256 is all we have, right? But the answer, I'm going to add them together, right? After converting them to U64s, but the hash function itself is just 256, right? So I do as characters. I'm wondering if I can just use the default hash in Rust, but whatever. Let's just do it normally.
Hi.
Hi. Oh, Rook Rules. Hello. Hi. How are you doing? With the two crab games you put out recently. Love the Dumo one. What is the Dumo one? The Sumo one? Where you were pushing the crabs? That one was multiplayer, I'm assuming. Did you play it solo? Or with someone else? Because it's one of the only games that I made that can only be played in multiplayer, I guess. Good with your Discord? Nice. Alright. I'm doing the advent of code right now, no game development. In case you're wondering, I'm just solving some programming puzzles. Hey man, any tips for someone who wants to become a dev but is afraid to take the lean into a different career path? Just try doing it. If you like it, then go for it. If you don't like it, then why are you trying to go there? If you like it, then you don't need to like just switch your careers immediately, right? You can learn new things without the in your free time, right? I'm not sure. That's a good advice, but I think it is. Okay, so we go over the characters and we say that result is result. I am going to add this as U8, so the ASCII code multiplied by 17, and then reminder by 256. Overflowing add. Multiply by 17. What is overflowing add? Hello, I want to see the docs. Returns the tuple of the addition with a boolean. Okay, so we just ignore the overflow, and then we do overflowing multiplication by 17, right? And this is the new result. Day 15, let's run it. Okay. Well, I obviously did calculate this wrong. You've taken a course of Python and enjoyed it a lot? Alright. Well, also, like, you want to, like, figure out what exactly you want to learn, maybe. Like, if you're trying to change the career, actually, then there's, like, a lot of ways to be a developer. You can be developing a lot of different things. And depending on what you want to be developing, you can choose like a language to learn or the tools. Python is good to get started with programming in general. But why is my chair shaking? Because I'm shaking. Why is that? No reason. Earthquake, yeah. It's an earthquake, Supercuber, because your mom entered the room. I'm sorry. But you started doing this first. um so what's wrong? What's wrong? Let me see. I want to do some debugging here. So for this string, the result is this, right? So there is an empty line for some reason. Oh, because this is the last one. I see. Okay. Oh, wait, hold on. It's because this is not the example. I need to run it on the example. OT7 231. Okay. Okay. It was actually the correct. I was running on the actual input instead of the example. Okay. So let's just submit this then, and this is the right answer. Do you like talking to the enemy? Why do men not like JavaScript? Talking to the enemy? Oh, what do you mean talking to the enemy? All right. Talking to someone who you disagree with. Well, is everyone who you disagree with is your enemy? Is that how you're... Okay, well, I like arguing about things, sure. Is that what you were asking about? You are becoming my enemy on purpose? All right. Okay. So what are we disagreeing about? You said that why do men not like JavaScript? Is that what we're going to start the war about? The programming languages, right? What programming language is the best? Well, obviously it's Rust. It's like not even like no one is even arguing about that, right? But JavaScript obviously is the worst one of the worst ones. But it's same as Python. Python is also pretty bad, but like getting started with JavaScript is still good. It's like one of the foundation languages. So it's good to learn it, even although the language is bad. Rust is not the best. No, Rust is obviously the best. What do you mean? Guys, I need to read a little bit here. We need to solve the part 2. You convince the reindeer to bring you the page. The page confirms that your hash algorithm is working. The book goes on to describe the series of 256 boxes numbered 0 through 255. The boxes are arranged in a line starting from the point where the light enters the facility. The boxes have holes that allow light to pass from one box to the next. All the way down the line, inside each box, there are several lens slots that will keep a lens correctly positioned to focus light passing through the box. The side of each box has a panel that opens to allow you to insert or remove lenses as necessary. Along the wall running parallel to the boxes is a large library containing lenses organized by a focal length ranging from 1 through 9. The reindeer also brings you a small handheld label printer. The book goes on to explain how to perform each step of the initialization sequence, a process that it calls the Holiday ASCII String Helper Manual Arrangement Procedure, or HashMap for short. Each step begins with a sequence of letters that indicate the label of the lens on which the step operates. The result of running the hash algorithm on the label indicates the correct box for that step. The label will be immediately followed by the character that indicates the operation to perform, either an equal sign or a dash. If the operation character is a dash, go to the relevant box and remove their lens with a given label. If it is present in the box, then move any remaining lenses as far forward in the box as they can go without changing their order. Then move any remaining lenses as far forward in the box. Fill in any space made by removing the indicated length. If no length is then box, then nothing happens. If the operation character is an equal sign, it will be followed by a number indicating the focal length of the lens that needs to go into the relevant box. Well, by the number indicating the focal length of the lens that needs to go into the relevant box. Be sure to use the label marker to mark the lens with the label given in the beginning of this step so you can find it later. There are two possible situations. If there is already a lens in the box with the same label, replace the old lens with the new lens, remove the old lens, and put the new lens in its place, not moving any other lenses in the box. If there is not already a lens in the box with the same label, add the lens to the box immediately behind any lenses already in the box. Don't move any of the other lenses when you do this. Why is Rust better than assembly? Because it's easier to write code, and there you go. Advent of Java, the 1000 lines of code has all the indents removed. Reconstruct the indents and execute the code. Python. Advent of code more like global warning generator. This is so much text, I don't understand what was written to me. What did I just read? Here's the contents of every box of each step in the initialization sequence above, which is... What is the sequence above? Oh, I see. It's equal or minus. Okay. Okay, so we do Rn equal 1, right? So we calculate the hash of Rn is 0. So in the box 0, we're going to insert the 1. So we have in this box Rn1, Cm's minus. I guess the hash of this is not 0, so we don't do anything. QP3 is going into a different box. Cm2 is going to the right. So why is this one going to the right? Did they not say that if there is already a lens in the box with the same label? Oh, okay. So, but there is not the same label. Okay. So the label is different, actually. But the hash is the same, so they go into the same box. Add the lens to the box immediately behind any lenses. Behind means to the right. So to the right is behind, apparently, right? PC4. OD9, yeah. AB5, sure. Okay, and then we do PC minus. So when I would do the dash sign, go to the reference box and remove the lens with a given label. And then, yeah, okay. Without changing their order. Does the order of the lenses even matter in this problem? They say remove without changing their order. Why does the order of the lenses in the boxes even matter here? Because there can be only one with the given label. Did anyone solve this one already? Why is the order even mattering? Why are they talking about this here? I don't see that it matters at all. Maybe to calculate the answer? Oh, the slot. Second slot, first slot, second slot. Okay, third slot. Okay, I see. Because we use it to calculate the answer. To confirm that all of the lenses are resolved correctly, add up to the focusing power of all the lenses. The focusing power of a single lens is the result of multiplying together 1 plus the box number of the lens in question, the slot number of the lens within the box, the focal length of the lens. At the end of the above example, the focusing power. Okay, so we just like do this and then we calculate that stuff. Okay. Sure. 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 It is day 15, part 2. Okay, well, let's see. The first thing, so the hash is the function that we're going to have still, right? Okay, so we do input split, comma, this is the commands, right? For command, and input split, comma, and then command trim, so that we remove the white space, because we don't actually have the white spaces there, I think. So then I do if command strip suffix of the dash, then it's the dash command, some label. Over here we remove the label, otherwise we have the label and focal length, right? Which is going to be command split once using the equals. We can unwrap here, and then focal length is going to be parsed. Focal length is going to be parsed. And now we actually do these commands. Okay, so here's what we're going to have here, right? We have the box, right? Boxes is a list of boxes. And a box is a list of lenses which are there inside, right? And then the lens is something that has the label. And has the focal length, right? like this. So I have 256 boxes using the hash. We can get the box properly. Let's start with inserting. So when I am inserting, it means that boxes get mute at the index, which is hash of lens label. Well, if it's there already or not. Okay. We're basically implementing the hash map here. Yeah, I see it. I never did it manually myself. So I guess I need the thing to remove the lens with a label from there, right? Remove. Let's do the hash map. Hash map. The actual hash map that we are implementing, right? Inside is the boxes. Okay, and then I'm just implementing the interface here. Are we getting APL event of code from Kubernetes soon? No, we're not. Or you are trying to push the APL? No. Never. Okay, so over here I do remove from self using label, which is this. And this is going to give me an optional lens. Why am I stuffing boxes of vec into vec of lens? I can do an array instead. If you want that. I just use the default here. Default is not satisfied. All right. There you go. Yeah. So over here, when we do the minus, we just do map, remove, label, right? And we ignore whatever we have removed. And over here, I am going to hold on. What are we doing? If it already exists, then we replace in its place without moving anything. Okay, I see it. We have remove and we have insert. I mean, the way you do it is probably clever, but as a non-rustacean whose brain not yet been oxidized, I have been hard time following. So if you can explain the types a bit more, that would help. Well, VAC is just a list. So a list of lists means that I have lists inside my lists. It's pretty easy, right? It's a two-dimensional array basically or something. I'm solving this. Like, are you familiar with the problem statement here, what we're trying to solve? Because I don't think I'm going over that again. I'm sorry, it's a long statement there. Took me a while to read. Lenses from the problem, yeah. We're storing lenses inside boxes. And we're following the commands. Why is it called boxes if it's just lenses? Well, it's lenses are stored in boxes. Lenses are stored in boxes. So box index is the hash of the label. So we do for lens in self boxes. Oh, wait, hold on. Self boxes box index. Can I remove what? No. I can remove at an index. Okay, lens index. Fine. So lens index. This is the box, by the way. Box. Unfortunately, the box is the keyword in Rust. So the box itself is the boxes at the box index, and then the lens index is going to be the box position of the box of the lens, which has the label equal to the label that we're searching for, right? And then we remove it and return it. There you go. So this is the remove thing. The only thing is, like, we are iterating over it sequentially, but I am assuming that that's should be okay. No problem for performance. It depends on the data they're giving us. Okay, and then insert the lens. I'm just going to try. So I'm finding the box index, and the box label is the label of the lens. And then I either have already a box there, some existing lens. I can find existing lens which has the label equal to my lens label. Then I just replace it. Right? Otherwise, I am putting it to the end of the box. So I'm just pushing the lens to the end of the box, right? There you go. So this is me following the commands, and the next thing is calculating the actual answer in the end, right? Okay. Answer is map boxes iterate enumerate map box index and box so for every box we are going to get all the lenses inside, right? So the box iterate enumerate map sum. So over here we also have the lens index and the lens itself, right? So I'm getting the box index. So box index plus 1. Box index plus 1. We multiply this by lens index plus 1. And then we multiply this by lens focal length. Right? And then we add all of these together. I guess I could instead like flat map here. And then calculate this sum instead. Right? Okay, day 15. Part 2. Example. Okay, so there you go. I have a total of 145. I should probably remove the debugging of the hash because I got the correct answer. So now I don't run it on the example, but on the actual data. And this is our answer. Okay. So this problem was very simple. It's just like you need to implement the thing that they have described. Pretty straightforward. Day 15. Okay. Now I have day 16, 17, and 18. From what I have heard, day 17 is the hardest one. Is that right? Badcop said that it took her 7 hours to solve. That's all I know about that. Day 16, the floor will be lava. With the beam of light completely focused somewhere, the reindeer leads you deeper still into the lava production facility. At some point you realize that the steel facility walls have been replaced with cave, and the doorways are just cave, and the floor is cave, and you're pretty sure this is actually just a giant cave. Finally, as you approach what must be the heart of the mountain, you see a bright light in a cavern up ahead. There, you discover that the beam of light you so carefully focused is emerging from the cavern wall closest to the facility and pouring all of its energy into the contraption of the opposite side. Upon closer inspection, the contraption appears to be a flat, two-dimensional square grid containing empty space, mirrors, and splitters. The contraption is aligned so that most of the beam bounces around the grid, but each tile on the grid converts some of the beam's light into heat to melt the rock in the cavern. You note the layout of the contraption, your puzzle input, for example, this. This is our example for day 16. Let me also day 15 commit that. All right. So this is now day 16. The beam enters in the top left corner of the left and heading into the right. Then its behavior depends on what it encounters as it moves. If the beam encounters empty space, it continues in the same direction. If the beam encounters a mirror, the beam is reflected 90 degrees depending on the angle of the mirror, for instance. Yeah, okay, this is all right. And then if the beam encounters a pointy end of a splitter, then the beam passes through the splitter as if its splitter were... The beam passes through the splitter as if the splitter were empty space. For instance, the right moving beam. This will just continue. So why is it called a splitter? I think it's going to be in the... Oh, it's if the flat part, then the beam is split into two beams. I see, okay. Alright. We split the beams. Beams do not interact with other beams. A tile can have many beams passing through it at the same time. A tile is energized if that tile has at least one beam pass through it, reflect in it, or split in it. In the above example, here is how the beam of light bounces around the contraption. It's pretty simple. I understand it. The beams are only shown on empty tiles. Arrows indicate the direction of the beams. If a tile contains beams moving in multiple directions, the number of distinct directions shows instead. Okay. So like I go to the right, then I split, it starts going down, then this splits left and right, this goes up, this goes to the right, and then over here down. This splits left and right, and this splits down. Yeah. Ultimately, in this example, 46 tiles become energized. The light isn't energized enough tiles to produce lava. To debug the contraption, you need to start by analyzing the current situation. With the beam starting in the top left heading right, how many tiles end up being energized? Okay. All right. Let me get the puzzle input. Okay. I'm going to convert the input again into the map, which is going to be input lines. And for every line, I'm going to match on the character. And let's see. So if this is going to be let's just call it mirror. Maybe there is a better name for it. And this is going to be a backward mirror, for example. This is going to be a vertical splitter. And this is a horizontal splitter. And this is an empty tile. All right. So this is the map that we have now. And what I'm going to do is to just run this. I see. So the part one is pretty easy. So many collects, just 2 collects for the outer vac and the inner vac. Is there a map variant that does not need collect? Of course, you like if you don't collect, then this just gives you an iterator. But I want to collect those into a vec to store it. But you don't need to collect. If you just iterate over things, you don't need to collect. Collect is to collect, to put it into the storage, which is the VEC in my case. All right, so here's what I'm going to do. Mark tiles. I'm going to have the map. Let me make this a method on a struct solver map. Solver of the map. Solve. I get to implement a beam search, right? Yeah, beam first search, exactly. Exactly. So I will just beam search uses breadth first search in its search tree, and each level of tree generates all successors of the tree at this current level, sorting them in increasing order of heuristic cost. But the most promising node in a limited set reduces its memory requirements. It only stores a predetermined number of best state in each level, called the beam width. Alright, yeah. No, not exactly this. Not exactly this. This sounds like a good algorithm that I could have used in my end game, though. Instead of doing the regular... I mean, I did something completely different, but still. Sounds something like a good algorithm for a game. It's like an A star, but without the weights. How's the end game selling? We'll see. When's the Bevy Jam even ending? Jam? Bevy Jam? The voting ends in 11 days. That's when we will know. I have some comments though. Over here. What is the Bevy box doing? You upgrade it to start the Crab Brave. Yeah, but people were like confused what things were doing, what buildings, because I did not have any instructions for the player. So people were confused a little bit. Okay, so I'm going to store the tile that I have visited. Visited tile is going to have its row, it's going to have its column, and it's going to have the direction of light, because that also matters. The direction of light also matters, you know? All right. So solver is going. What solver is going to do is we're going to calculate the answer. So I'm going to visit, self-visit. All starting from the position, which is going to be the row 0, column 0, so the top left corner, and the direction is going to be direction right. Right, so I visit all the things, and then I will calculate some things based on that. Right, so in order to visit everything, position, I guess I can call this position of the light, which is position plus the direction, basically, right? So I basically say that if I have visited this already, then I just don't do it again, basically. Otherwise, I continue based on the map at the row and the column, right? And if I'm outside, I'm guessing I should okay, none means that I'm outside. And then we have some empty tile, right? We have some mirrors. Horizontal splitter. And the vertical splitter. So we need to like implement these things. So over here, if it's empty, then I need to go in the direction, right? So I do self-visit, the position plus position direction. All right. Let me implement this. Implement for the implement add direction for position. Hello? std ops. So output is self. Then when I'm adding the direction, self, well, I guess this is not usize then. If I want to be going outside. So let me convert the direction. Delta row and delta column is direction delta. So I say self row is self row plus delta row, and column is self column plus delta. Column direction is still the same. I mean, we override the direction actually. Let me implement this position
function go in this direction, basically. Instead of add, I say position go in this direction because I'm overriding it. Okay, and then we have the for the direction method delta, which is going to return a tuple for row and column. So if we go up, then row is -1. We go down, then row is 1. We go left, then it's 0, -1. If it's right, then it's 0 and 1. So over here also I get self get tile at the position row and position column. Get tile row column optional tile. So I say self map get row try into question mark get column try into question mark question mark. The last question mark is unnecessary, I guess. Type annotations are needed. Wait, what? They are needed indeed. Because try into doesn't really work. Can I try into is like the worst thing. Try into usize. Try into row. Right? And over here it's going to be the column instead. Okay, and then we do the copied. Or I can do it like this, sum tile. Okay, there you go. Now, if we have the back mirror, then I'm going to rotate myself 90 degrees. Right? New direction is going to be matching on the current direction. If we were going up for the back mirror, then we're going to start going left. We're going down, then we start going right. If we're going left, then it's up, then it's up. We're going right, and we go down, right? And we visit position go into the new direction. Good memorize position direction to stop the search. Or memorize position direction, what? If I am in the same place twice, in the same position with the same direction, then I'm not going to do it. So that's exactly what is this? This is already done, if this is what you mean. Okay, and then for the regular mirror, if we're going up, then it's right. If we're going down, then it's left. If it's left, then it's down. And then if it's right, then it's up. Right? Horizontal splitter now. Horizontal splitter is also, I'm going to match the direction. If it was direction left, or if it was direction right, then we just continue. Then we just continue in the same direction that we were going, right? Otherwise, if it's up or if it was down, then we split it in both directions, right? And we split in both directions, so we go both left and right, basically, right? And then we do kind of similar thing with the vertical splitter. And none means that I'm outside of the map. So vertical splitter. Direction could also be radians. Mirror rotations would be trivial. And no types needed. I think this is easier to read though. Instead of radians though, it could be an integer angle, which would be like 0 is right, 1 is up. So it is like the multiplier of the 90 degrees basically, you know? And then you could do a little bit of math there instead of doing this. I don't know. I think this is easy and easier to read here. Maybe, I don't know. In the Linksider, we actually have the type that's called integer angle, which is doing exactly that, but it's not a radians. It's error prone, but it is error prone to do it in radians too, because you can, if you do it in radians, then you can do half of an angle instead. So you want to limit yourself to only 4 directions, right? I could use something like the integer angle that we do in the Linksider, like I was saying. But I don't know. I think this is not hard. I don't think this is very error prone. What, this over here is just like 4 lines. Up, left, down, right, left, up, right, down. It's like how your brain works anyway, I think. I don't know. Int angle as in int times p divided by 2. Yes, exactly. So I have 2 separate angle types when I'm working on Linksider. One is the integer angle and one is the regular angle, which is like the radians, right? And I can convert between the two depending on what I'm doing. Like for rendering, I'm using regular angles, and for the logic, I'm doing the integer angles. I could like import that my own library, I guess, here. But nah. Let me just keep going here. Okay, so vertical splitter, if I was going up or down, then I'm just continuing the same direction. But if I was going left or right, then I'm going both up and I'm going down. All right, so now that I have visited everything, this is all basically. This is all. Now that I have visited it all, I just do what? 46 tiles. I just calculate the tiles that are energized, right? So I'm just doing self visited into iterator map position. So for the position, now I'm going to discard the direction. I'm going to discard the direction, and I'm going to only use the row and column and calculate the distinct number of those. I'm going to collect those. I'm going to collect those into a hash set, right? So that everything is only once there, and then I get the size of that, and this is the actual answer. Is there a way to like calculate the different duplicates by maybe in itertools? Count distinct, maybe? Distinct? I don't know. There is no such method. So this is how I'm doing it. I just collect it to a hash set instead. And just print out the answer. Okay, so if we do day 16, part 1 example. Then the answer is 1. Amazing. What is my example? It's a dot, right? Oh, wait, hold on. If insert, this returns true. If we are inserting. So if I'm not inserting, which means that I have been there already, then I do the return. Okay. So I have calculated the 52 tiles, though. Okay, well, I mean, okay. Okay, I mean, I see it, I see it. The problem is that I'm, like, getting the... I'm hashing the tiles that are outside of the map too here. You know? So I can do something like let some tile be self get tile at the position row and position column, otherwise return. So like if I'm outside of the map, then I'm going to return it immediately. Otherwise I'm going to insert it into the over there, and I'm going to match on the tile, and no need for me doing this thing like that, right? Okay, now it's 46. Okay, and now I just run on the actual thing, and we get the answer. Alright, this is the right answer. If you use some pronunciation services like translate.com and put radians, can you hear the difference? Again, the types didn't save us from the bug. Yeah, this time... so like the insert API returns a boolean, but so here's the thing. Here's the thing in Rust, right? If you take a look, the reason I made this bug, let's go into the docs of the STD. Let's take a look at the hash set, and we have the method that's called insert, right? This returns true if the thing previously did not contain a value, right? But then, if you take a look at the API of a hash map instead of a hash set, right? And you have take a look at the insert, this returns an optional previous value. So if there was a value before, then I return that value. Otherwise, I return nothing, right? So for me, when I return something is the similar thing to true, and when I return nothing, it's similar to false. So I was assuming that I should return true if there was something before. But yeah, so yeah. I think the Rust STD sucks and non-uniform sucks even more. No, I think it's okay, but I am still confused a little bit. Also, in like the hash map and the hash set, they are not very... I mean, they are good enough for a lot of use cases, but there's wait, in the current Rust, can we make a generic like map set API or no yet? I don't know. Yeah, it is pretty decent. I'm just it's not going to be changed anyway. But some things like this, like I actually would prefer if this hash set also would return to me an optional thing. An optional thing that was there in before. Because even when I'm inserting into a hash set, there could be a different like value before, even although the hash is the same and the values are equal, it could still be like a different thing, even although they're equal. There's, oh wait, hold on. But there is also the method like this, exactly like I wanted, replace. So replace returns the optional. Replacing the exception returns the replaced value. So this is the API that I actually want to be the, like, why is there, what is the reason? Like the booleans, the true and false is is like I just think in general a boolean is a bad thing. Like returning a boolean is bad, I think, in general, because you need to look at the documentation to see what the boolean actually means, you know. But when you return an option, it is much more obvious. I think it's just in general. I don't like the booleans. I mean, you can make the method that says like, is the tile like occupied, for example, right? If the method is like a question like this, then you can get an answer which is true or false, right? If the question that you asked like gets you an answer which is yes or a no, then yes. But when I'm doing the insert, like, right, why is this returning a boolean? This does not make sense to me. So like for that reason, it's easy to make a bug here, I think. What is the answer to the insert question? That's why not. What should the insert return? What would it return otherwise? The replace method returns optionally previous value. So this replace is sum. So if I have actually adds a value to the set, returns the existing value if any, if and nothing otherwise. Wait, hold on. I'm confused about the replace though. Replacing the existing value, if any, that is equal to the existing one. What if it's not there? Then I want to insert it though. So I want the insert to return me the optional thing. Yo, I'm really stuck with a specific code at the moment. It's about ray tracing. Are you able to help me, please? Would mean a lot. Okay, sure, you can give a link, but I hope it's not 1 billion lines of code. If it's 10 lines of code, then it should be okay. Hash set insert is different from hash map. Exactly, yeah, that's what I was talking about. I don't like they are different, and that makes me confused because I'm used to hash map insert returning an optional thing. And then when an optional thing is something, it is like when I convert that to a boolean, I'm usually like some is true basically and none is false, but in the hash that is inverted. It kind of makes sense. Yeah, it does make sense, but it still is like I think it's confusing. Same solution, switch inside switches, like you did. All right, let me look at the part 2 though. It's a Roblox game and it's 40 total. I don't know Roblox. Do you want to get an option K that would return some value? It'd be like you insert A and get the same sum A. No, if I insert something in a set and if the value was already there, it can still be like a different like value technically because so I want to return the old one, just like the replace method already exists on the hash set. I don't know, maybe it's like for optimization, for example, right? If you do an API like I say, then it would be like can it be optimized, me actually getting the value and checking that if it is some or no? All right. Okay, give me the link to the code or I cannot take a look at it. Malignus. Otherwise, I will continue to the part 2. Hi, message clone. Hello, chat. Alright, let's continue to part 2. As you try to work out what might be wrong, the reindeer tags on your shirt and leads you into a nearby control panel. There, a collection of buttons lets you align the contraption so that the beam enters from any edge tile and heading away from that edge. You can choose either of 2 directions for the beam as it starts on a corner. For instance, if the beam starts in the bottom right corner, it can start heading either left or upward. So the beam could start at any tile in the top row, heading downward, any tile in the bottom row, heading upward, any tile in the leftmost, or over there. Okay. So anywhere on the edges. To produce lava, you need to find the configuration that energizes as many tiles as possible. Well, judging by the thing, it's going to take us no time to do it because it runs instantly, 0.27 seconds. That's for the compilation. Hello streamer, how many unwraps is 1 null worth? Infinite null is a crime. Isn't there nulls in Scala? Wait, hold on. Is Scala should have nulls, right? Because it's working on the Java. It's working with Java. There should be nulls in Scala, no? Can you post in a Discord server? You can post a link over here in chat if you want. You cannot post links, because technically it's in the game development thing. I don't know. How about you ask your question in the community which does Roblox? Maybe there should be other people who can help you. I mean, you can post in the Discord server, sure. I'm just not sure. What can you post there that you cannot post here? If you do it properly, you won't get any nulls. Yeah, sure. That's the same about Kotlin. I tried Kotlin and then it was a pain. Even although technically, if you do it properly, you won't get any nulls. And it's like type save, but then it's not really. It's 1000 word limit. You can put it on a website like a gist, for example. Look at this over here. You go to gist.github.com, go over here, or pastebin.com, and then you put your whatever thing here. You can name it like file.py if it's Python or if it's some other language, and it will have highlighting too. You create a secret gist and you put a link that you get as a result. How many tile? Find the initial beam configuration that energizes the largest beam of tiles. How many tiles are energized in that configuration? Okay. So 51 tile is what I should get for the example. Part 2 example. Okay. So here's what we're going to do. This is the solver. Right? And I'm going to solve with position, right? And I'm going to just visit using this position, and this returns me the answer, which is the number things, right? So if it's part 1, then I just do solver new map. Let me do the constructor here too. Function new map. right? Solver new map solve, and this is the position is going to be the row 0, column 0, and direction is right. So this is the answer for the part 1. And then for the part 2, I'm going to do it for all of the parts, right? Where I can start from, right? So for row in 0 to map length, I do... Okay, hold on. 0 map length. Map. Row. Solver. New. Map. Solve. Position. Okay, so we start at the row. Column is going to be 0. Direction is going to be right. Right? So I'm going to chain multiple things, and I'm going to find the maximum of those, right? I can just return the positions here. Make it a little shorter. A map position to solver new position solve. No, we solve using the position, and over here do the map. Clone. And we get the maximum, and we can unwrap that. If and else have incompatible types, because semicolon should not be there. All right. So now the row. We do it like this. Okay. And then we start on all the different sides, right? So we start at the left side, going right, or we start at the right side, which is map length plus -1. This is us going left. And then we go into the columns. And we go into the columns. And we start from the row 0, which with the direction down. And then we start with the bottom row going up. Right? So these are all the directions that we need to try, and then we try to solve it, and we find the maximum, and this is our answer, right? Part 2, the answer is 51, and then if we do it without the example, and it's going to run for a little bit, so this is not the best, but I did do the debug build, not the release build. It was still pretty fast. This is the actual answer. This is the right one. Okay. So we have solved it, and Lignus have solved the gist. All right. Let's see. We have code here. This is the Lua. All right. Let's see what's happening here. So what exactly is not working? User input service, camera, current camera, GUI, script, parent, item, null. Amazing. So mouse cast is what we're doing. We get the current mouse location. We calculate the mouse ray viewpoint to point to ray using the mouse position, sure. Then we get the raycast result. We raycast using this ray. Why are you multiplying this by 1000? What, I mean, I need to, I don't know what the raycast function is doing. That's not your function. But it seems weird that you're multiplying this by 1,000 here. Is this taking 2 points and then finding something in between these 2 points? For line 5 and line 19 not printing, clicked in the output. Line 5 and line 19. Line 5 is local GUI script parent. To make it's, yeah, I don't know, there's nothing being printed here. Line 20 over here we have the clicked. GUI spawn activated connect. In order for me to understand this, I need to know the what this is created for, which is Roblox, and I never did anything in Roblox, so I don't know what this is. I don't know. I mean, I can understand what this means, even although I have not seen the documentation. I can kind of guess what this is, but when you say that GUI spawn activated connect, I don't know what this means. For example, so you connect to the activated event when someone spawned. So there's a spawn button on the UI, and when it's activated, you do the click. Why not clicked? Why activated? User input service input began. Like, this code has nothing to do with this, from what I can see. What does the raycast has to do with the GUI spawn activated connect? If you... How about you ask in the community of the Roblox people? They can probably help you more than I can, because I have never touched Roblox. There's probably like a lot of places where you can ask questions and people will be able to know it. But from what I can see, this is completely not relevant to the raycasting, because this is just when you activate the spawn of the GUI, which is not connected to the raycasting at all. The mouse cast is only used in the render step, so it is irrelevant to the GUI. Is that Arch Linux? No, I'm using NixOS. Arch Linux is in the past. Alright. The button is child of the screen GUI. I finally activated my Linux. No, I finally... Yeah, I forgot. I forgot all that thing. I'm sorry. Alright. I go back to the advent of code. Like, I don't know that the button is the child of the GUI, yes, but why does it doesn't make sense. Like, why is the raycasting there? The raycasting is not part, that is not child of the GUI. It should be local GUI is script dot parent instead of comma parent. Oh, I see. Yeah, it actually makes sense over here, script parent, because script is the child of the GUI. Okay. And that's how we get the GUI itself. All right. Yeah. So the problem is not in this code, but over here. Makes sense. Look at this lava flowing there. All right. It's interesting. Like, are you not getting the error message when you try to run that code though? That the comma is not working? That, like, if you don't get the error message, then I don't know. I guess it's Lua. Commas. should be disabled. When are we getting the Linux activation reveal hot tub stream? Okay, 17 day. I was told that this one is hard. This one is hard. They told me that this one is hard. Let me commit the day 16 though. Let's read this. The lava starts flowing rapidly once the lava production facility is operational. As you leave, the reindeer office offers you a parachute, allowing you to quickly reach Gear Island. As you descend, your bird eye view of Gear Island reveals why you had trouble finding anyone on your way up. Half of the Gear Island is empty, but the half below you is a giant factory city. You land near the gradually filling pool of lava at the base of your new lava fall. Lava ducts will eventually carry the lava throughout the city, but to make use of it immediately, elves are loading it into large crucibles on the wheels. The crucibles are top-heavy and pushed by hand. Unfortunately, the crucibles become very difficult to steer at high speed, so it can be hard to go in a straight line for very long. To get Desert Island, the machine parts it needs as soon as possible, you'll need to find the best way to get the crucible from the lava pool to the machine parts factory. To do this, you need to minimize heat loss while choosing a route that doesn't require the crucible to go in a straight line for too long. Fortunately, the elves here have a map that uses traffic patterns, ambient temperature, and hundreds of other parameters to calculate exactly how much heat loss can be expected for a crucible entering any particular city block. For example, each city block is marked by a single digit that represents the amount of heat loss if the crucible enters that block. The starting point, the lava pool, is the top left city block. The destination, the machine parts factory, is the bottom right city block. Because you already started in the top left block, you don't incur that block's heat loss unless you leave that block and then return to it. Because it is difficult to keep the top heavy crucible going in a straight line for very long, it can move at most 3 blocks in a single direction before it must turn 90 degrees left or right. The crucible also can traverse the direction. After entering each city block, it may only turn left, continue straight, or turn right. One way to minimize heat loss is in this path. This path never moves more than 3 consecutive blocks in the same direction and incurs a heat loss of only 102. Directing the crucible from the lava pool to the machine parts factory, but not moving more than 3 consecutive blocks in the same direction. What is the least heat loss it can incur? Alright. The only place you use Lua is the NeoVim config. Yeah, and I don't think it's a good language for config, honestly. I mean, similarly to JavaScript being a bad language, so there ICLava is using the Teal language, right? Teal language. The Teal compiler. So this is the basically like TypeScript for JavaScript, but instead for Lua, which adds types on top. I'm not sure. Maybe this makes it better. Do they have a website? I don't know. But yeah. Dynamic programming for route finding. It's not dynamic programming, it's just regular path finding here. We need to find the shortest path from the top left to the bottom right. But our position is not only the position, it's also the direction, and it's also the amount of blocks that we can move before we have to rotate, basically. So yeah, and then it's just the regular A star Dijkstra, I guess, is what I'm going to write here. Not shortest path, but minimal heat loss within force swerving. Well, yeah, but it's like the shortest path, exactly. Lua being better than Vim script is true. I guess that is true. If I was going for a scripting language, then I would use JavaScript though instead, even though JavaScript is a horrible language. Instead of Lua, JavaScript, just because it's popular, I would use that instead. And then you can convert it to TypeScript, and it's even better. Just use TypeScript, yeah, I guess. On a Trust script. I'll just use Haskell for all scripting purposes. Haskell compiler, I don't know. It requires too much work to set up. The tooling of Haskell is bad, I think. And there are other things that I don't like about Haskell. Being like only functional language is something that I actually don't like. Rust is better. Day 16, day 17. Example. I'm just bad at monad transformers. Well, monad transformers are... I'm not the only one who is bad at them. Even people who are using Haskell are saying that they are unusable. Can't you just use some existing VM with Haskell installed and never worried about how it's getting installed? VS Code uses JavaScript. Yeah, and you see how many people are making the plugins for the VS Code, because it's easy, it's approachable, everyone can do it, right? VS Code is nice. Is like the one advantage of Lua was for a long time that it was like small and like kind of fast out of those interpreted languages, but is Lua actually faster than JavaScript these days in 2023? Maybe it was slower before, but I think JavaScript is like pretty good now, right? Also, doesn't Nix make something like Nix, Pro Packages, Haskell, Debian, available, and everything just magically works? Not everyone is using Nix. So map is going to be list vec of the losses, right? Which is going to be just the integer or something. U64, sure. Map line characters map character to digit of 10 unwrap select. Wait, hold on. 2 digits returns an optional U32. Sure, let's make it a U32. There are definitely more than enough plugins for NeoVim. I'm not missing anything. You're not missing anything until you try something and you know that you miss it. You can use the base Vim without any plugins because you never tried it or something. I would use Vim, but I'm missing things there. And in VS Code, I don't even need to configure anything and they're already there. And also the plugins for NeoVim are of worse quality than plugins for VS Code. I think that can be said that it is a fact. I have seen a bunch of bugs in NeoVim plugins. Take a break, think for a moment, why on earth this would be a hard problem? So far we haven't figured out why this would take longer than an hour. Well, I mean, because in Bash, how do you do the, like, how do you do this in Bash? Is the thing, right? It's hard to do it in Bash, I think. Right? So I'm going to have position, which is going to be row.
Hello there.
Hello, Gordienka. We have column. We have how many do we need to move consecutive blocks. So like must rotate in this many blocks, you know, in this many moves. And we also have the current direction. So we do have the direction here, by the way. We do have the direction here. Direction. Let's write this time the integer angle, right? And the vex to struct vec2. Let's use the integers here, sure. We do this, and then we have the direction with an integer inside, basically, right? And then I have for the direction, I have consts, which is going to be right, which is going to be day 17. Yeah.
Hello, Petkov.
To right, down, left, right, up. Okay. And we have position. Let's see what I will need a little later. Here's what I'm going to do. I'm going to... This one always broke you. So what did you do? Did you not do the like the regular pathfinding? I'm going to just write the Dijkstra here. Can you help me make my bash run faster than 7 minutes? I don't know. Did you do some other solution or is it just the Dijkstra? I mean, this is part 1. I don't know what's part 2. Let me solve this first. Why not dynamic programming though? This is branching out a bit less than order of 6. The dynamic programming is the problem with dynamic programming is it only works when your graph is does not contain the loops. So you cannot do dynamic programming when your dependencies form a loop, basically. For that, you need to do the pathfinding, basically. Why a tuple struct of int for direction? It's same for the link cider. Let me show you. I guess I want to move this into... Why the GitLab always signs me out? We have the integer angle, which is basically one of the 4 directions. It's like the radians, but we only restrict it for 90 degrees, right? So this is not public, so it is like the implementation detail here, technically. And I'm not supposed to like use it outside of the implementation of the direction. But I have a cool visualization for this one when you finish part 1. Okay, sure. Sure. So, like I said, I'm just going to do the Dijkstra here. So I'm going to have a priority queue. Which is basically the binary heap. In Rust, we have the binary heap. Is there in Rust a thing which is... I guess I can use the binary tree set. So that like in the binary heap to insert multiple... whatever. Let me do the binary heap here. Binary heap of... viewed position. So it's going to have the position inside, and it's also going to have the distance that we have calculated so far. And then we implement the ordering of that. Like this. Mm-hmm. And for these things, I'm going to derive partial ag, hash, clone, and copy. For this, this, and that. Is that a bauble in the puzzle data? What? Rust std in bash when? I think bash. I think Badcop can like make. You can make your own like standard library for things like that are used, right? Binary trees. You had to write your own heap. Yeah, makes sense that it took you 7 hours then. I mean, yeah, I don't know. It will take me like 100 hours to do it in bash, I guess. I think. So we queue something with the distance here. Okay. So we do, and we we also have the distances themselves. The distances themselves is going to be hash map. So I'm going to do this distances insert for the starting position. How to write that? I have the binary heap and I have the distance for every location, basically, right? And then we have this start point, which is going to be position. Position. We start where? Where do we start? In the top left, 0, 0. Must rotate must rotate in 3 turns. And direction. What is the direction that we start with? We can choose it. We can choose the direction in the beginning, right? I think so. I think so. So I have multiple starts then, which is I'm going to be able either down or right, I guess. So those are my directions, and for those, I'm just going to say that the distance to get to both of those is 0, and I'm going to queue them up, right? Queued position. Position and distance of 0. All right. Here's a clone program to check if the number x is prime. Thanks for that. Thanks for that. Okay, so now we just do while we have some queued thing in our queue. Right? I need to check the distance. So if distance is at the queued position is not equal to the actual queue distance, then I'm going to ignore it completely, because I'm going to queue things multiple times sometimes, I guess. Otherwise, I'm going to figure out which are the different ways I can move, right? So I either rotate or if I don't rotate. So like next moves, right? Next moves. Are so I'm going to do first of all, I can continue. I can only continue if let's do that position is queued position, right? So if position must rotate is not equal to 0, then I can move forward, right? Then I can move forward. Which means if I move forward, then I have the position plus position direction and position direction. So I'm going to return the position and direction without the actual... No. I need to do them all. Okay, so the position is going to be my previous position plus previous direction, right? Must rotate is going to be must rotate -1, so I must rotate in 1 less turns, and then direction is going to be the same direction. Okay. So here's what we need to do. We need to, for the direction, have a method to vec, right? So I'm going to match self 0 by 4. If it's 0, then I do 1 0. If it's 1, then it is 0 1. If it's 2, then it is -1 0. And if it's 3, then it is 0 -1. Okay. And then we can do implement add for vec. Okay. All right, there you go. So here's my first move that I can do. If I must not rotate right now, then I can go there, right? Otherwise, I can I can also rotate 90 degrees, right? So Kubernetes is such an efficient algorithm for solving an event of code. He even has batching. Where do I have batching? So here's what we are going to rotate, either to the left or to the right. So like -1 or 1. So I'm going to say that new direction is position direction position direction. Hello? Position direction plus this, right? Which is going to rotate it 90 degrees left or right. And I'm going to have the position at a new direction. Must rotate is 3 because I have 3 turns again. And then I have the direction, which is the new direction. I'm solving 4 problems on 1 day. Is that like... What's wrong with that? So for next position in the next move that I can do, I say that if distances... And then I calculate the next distance, right? Next distance. So we see what tile are we stepping on. Some tile is map get next position row map next position. Let me do this. I'm going to convert my map into a closure, which is going to take position in the form of vec2 and return me a u32 optionally. So I'm going to say map get position 0 try into. It's going to be like this. This is the row, and then we get the column. This is the actual tile. There's something wrong here. This is the row. This is the column. No, there is it's not formatting because I did not finish this one. Okay. Now we call std Dijkstra and it's done because Rust is for cheaters. I guess I could use some of the crates. It's not in std, but it's definitely on crates somewhere. I think you can just search for it. What's the generates the minimum pass using the Dijkstra algorithm? I'm wondering how good this is though. Pathfinding. Pathfinding might be the good one. This one has a lot of downloads. Let me see the documentation. std advent of code. Let's see. Over here we have the Dijkstra. Right? We have all the pathfinding. So what does it do? Algorithms for directed graphs. Dijkstra. Dijkstra. Compute the shortest path. Okay, so we give it start, which is a node. We get successors. Successors is a function from a node to the iterator of a node and the cost. Yeah. And this returns the optional path together with its cost. This sounds this is simple. Yeah, I could use this one instead. Probably more work to use than create than write it. I don't know. I think it's easy here. To use it. Maybe I should have used it. Dijkstra pretty simple, yeah. Well, let me finish this. I started writing this, but I could have used that crate instead. But I think if you are new to Rust, this can be scary, right? So for that reason, I have been like writing my own things in the beginning because you don't understand what this means. This is like, what the fuck? When you see it, when you just doing Rust for the first time, I think, right? It looks slenderer than C++. Simplest Rust function signature. It is pretty simple here. I would say this is pretty simple, but it also is like it could be less generic. So like the function could return a vec, for example, or a reference to a slice, for example, right? So that you don't need to do like this is a function that returns in, and in is the iterator of the tuples, right? Could instead be like just a slice of basically edges, outgoing edges for a node. The graph is represented in a function form here, basically, instead. Yeah. Anyway, so we have the next move. The move is not going outside of the map. So we calculate the new distance. It's going to be currently queued distance, and we add to that the tile, right? This is the new distance. So then we do something like match distances get for the next position. If it was nothing, I think I want to do a map or here. Distances get map or true, because like if it's non-existing, then I'm going to like queue it anyway. But if it was existing, like previous distance, then I want to only do it if the new distance is less than previous distance, because I want to find the shortest path. So in this case, I do distances insert new distance for the next position, right? And also I queue it up. Queue push queued position, where distance is the new distance and position is the next position. Okay, well this should basically be it. I think, if I did not do any bugs here. Cannot add integer to direction. Sure. So when do we... I'm such a good programmer, I don't even have to look up Dijkstra's. Did you have to look up Dijkstra's? I mean, I have written Dijkstra's for like a lot of times. It's like the basic program, like the BFS, DFS, and Dijkstra is like the most used things in the competitive programming. You never remember algos except the bubble sort? Now the bubble sort is something that I never written. Okay, so over here we say basically that if queued position is equal to map size is vec2 map length map 0 length. So we are in the bottom right corner when we are in position map size -1, right? So if we are there, then we can finish and we can print out the answer. Unreachable code occurred. Yeah, of course, because when you do this, div mod ram Euclid by 4 is what I want here. So it's positive. Okay, my answer is 97. Is that right? It's not right. Okay, well, I have a bug somewhere. Just 2 loops and a swap. Okay, I have a bug now. Which is what? Can I have a simpler example? This example is a little bit too big. Let me make this smaller. 1 1 1 1. The answer is 2, which is right, right? And if we do 2, then the answer is 2. If we do 2, the answer is 3. Can you print the path? I guess I can print the path. I'm not saving it, but I can. The answer is 5. This is right. Maybe I don't understand, right? We only add the cost when we actually go into the thing. Right? Maybe 3, 2, 1, 97. So my answer is smaller than the actual answer, which I'm assuming the problem is actually just in the queue, in the must rotates. So I am rotating. If my must rotate is 0, then I'm rotating for sure. Otherwise, I'm doing so 3, and I have 2. So we do 1. Yeah, I think it should be 2 instead of 3 here. And that's the yeah, okay, there you go. Now we have the correct answer. Yeah. It's because I must rotate after 2 turns. And the first turn I have already made, basically, when I'm doing the rotation anyway. Okay. So let's run this on the actual input. It is slow. In debug mode. Is it because it's in the debug mode? Or is it because... Slow. Mine took 90 minutes. Why is it slow though? What's the size of the map anyway? It should be not that big. I did a bug somewhere then. Hold on. It's because I made a bug. For sure. It is quite large. Open it in a new tab. I can try. Hello? Where's my terminal? Where's my terminal? I cannot launch my terminal anymore. Well, it's running very slowly, apparently. Let's print out the map size. My map size is 141 by 141. It's small. It's not that big. No. This is not a big number. This is not a big number. Maybe I did the ordering here a little wrong. Just use more threads. Hold on, let me print out over here maybe the queued thing. Like, where am I? Let me run this on the example again and see what am I doing here. So over here, look at this position, like before the end. was over here. Oh, because direction -44. Okay, I need to normalize my direction. That's what I forgot about. My direction is going infinitely, basically. 1 uptime. Hello there. Thank you for the raid. What was your stream? I'm assuming you were doing Advent of Code too? I'm solving day 17 right now. And I just realized that my direction should just be normalized. Direction. Let me do position direction plus rotation. Sure. So let me do this. For the direction, I'm going to implement add integer for direction, right? So self 0 is actually should never be anything other than 0, 1, 2, and 3, because that's important for me to only store my direction as 0, 1, 2, and 3. So I'm going to do self 0 plus RHS, and over here I'm going to do RAM Euclid by 4, and that's going to make sure that it is correct. Okay, there you go. There you go, and then we run not on the example, and it's instant, okay? 0.02 seconds. Stuck on the last day forever. Day 18. I am going to do it soon. I'm just finishing part 1 of the day 17. I don't even need threads, guys. I just had all of my directions going all the ways. So like I did multiple. I did count if I'm going in a loop, basically, as different places. All right, let's see. We have the visualization from Bad Cop in Godot. Wait, I thought you were doing Bash. Okay, I see. But this is the problem in this one is not even 3-dimensional, it's 4-dimensional, at least for me. Right? Because I have 2 dimensions for the map location. The 3rd direction is the rotation, and the 4th dimension is the number of things. Yours is 3-dimensional because you are not a noob? Oh, well, I guess you can like just have like and go like multiple. You can go like multiple cells at the same time, right? I see. But that actually means that you are calculating the same thing multiple times, no? I think. I guess it doesn't really matter. You're moving one of the dimensions from the storage into just the number of edges. I guess it doesn't matter. More edges, less nodes, yeah. Not sure if it's better. Well, it depends. It depends. It's better like if we're running low, if we were having memory restrictions, for example, sometimes you have to do things like that because like the memory constraints. But you also did an A star, so it's definitely better. A star is not hard to like change this to A star, I guess, but whatever. I'm not doing it. Let's do the part 2. The crucibles of lava simply aren't large enough to provide an adequate supply of lava to the machine parts factory. Instead, the elves are going to upgrade to ultra crucibles. Ultra crucibles are even more difficult to steer than normal crucibles. Not only they have trouble going in a straight line, but they also have trouble turning. Once an Ultra Crucible starts moving in a direction, it needs to move a minimum of 4 blocks. So the direction it can turn before it can turn. Minimum of 4 blocks. And then a maximum of 10 consecutive blocks. Okay. So 94 is the answer for the example, right? Okay, sure. Part 2 is weird. I guess let me do it differently then. Instead of must rotate, I will say moves without rotation. You know? This is what I'm going to store there. So moves without rotation is 0 in the beginning, right? When I actually do the rotation, moves without rotation starts becoming 1 because I did 1 move already after the rotation, right? I must rotate moves without the rotation if it's equal to 3. No, hold on. I can continue forward if it's basically like less than 3 here, right? And then over here we do moves without rotation +1 instead of -1 because it's easier to understand this way, I think. Okay, so it is the same answer. I'm assuming this did not introduce a new bug. So now I just do it differently. So this is going to be can continue forward. Is this for the part 1, right? And can rotate is true. Can rotate, then I can just filter. Like this. And then I can set up, can I continue forward and can I rotate basically here. So can continue forward and can rotate is going to be match like if part 1 then this and true, and if it's part 2 then I can move forward if moves without rotation is less than 10, and I can rotate if moves without rotation is at least what? At least 4, and at most 10. I think the only optimization you are missing is that you are using 4 directions, but you only really need 2. Why? Well, that depends on the input, I guess. That depends on the input. I guess it maybe it doesn't really depend on the input. Like, because every single character is a single digit, it like makes it restricts the graph that they are composing very much, right? If they could make bigger numbers other than like just 1 to 9, you aren't allowed to go backwards. It means that you cannot rotate 180 degrees, no? So you can make a path which goes right down, right up, right down. Technically, if they had a graph which is like 0 on the path and like 1 billion on the other parts. then you could have a zero cost technically if you just follow the zeros. Yeah. Doesn't matter, you still only need to track horizontal, vertical. Because you will not be going backwards anyway. Yeah, I see it. Yeah, I see it. I agree. Okay, so let's do this, part 2. And part 2, let's do part 2 on the example. It's 94. And then part 2 on the actual input is this. Submit. All right, that's the right answer. Hold on. So it took you 7 hours? You need to like improve your bash, I guess. Someone already said it cleared things up for them. How about that 7 hours was cursing ChatGPT to write me a hip, okay? Alright. Yeah, see, ChatGPT is bad. That's why I'm not using ChatGPT. It only makes you write bad things, which takes up your time. Alright, don't use ChatGPT. You would have probably made it faster if you just didn't use ChatGPT, okay? You saw it, but you don't quite get it yet. What are you talking about? The optimization that we are missing, that we are doing vertical or horizontal only. It's because if you are going to the right and then you go down, and then like because you are not having like both up and down, you can technically like in your like graph you are going to have the edge that's going backwards, but because when going backwards you are going to basically increase the cost anyway, you could have instead just went like up immediately, you know. So this is definitely a longer path than taking up immediately. So for that reason you can treat the both vertical directions as the same thing. So like going backwards is disallowed, but if you allow it, it will not it will not change anything because it's the longer path anyway. Right? Wait, hold on. That's actually maybe that's actually that might actually not be true in some cases. From disallows you. Yeah, I know, but it doesn't matter. If you allow it, it doesn't matter. The only thing that when you go backwards, you don't like reset your number of cells that you have moved so far. I guess, right? Wait, hold on. No. Maybe not right. Whatever. My solution is fast enough. Fast enough. It's it's running in 0.31 seconds. So I think it's good enough, right? I think it's good enough. All right. And then we do the last one. Day 18. Is this one hard? Or is this one easy? Thanks to your effort. Did you do this already, Badcop? Right? I'm assuming you did this. Oh, you did not? I thought you streamed already. You usually stream earlier than that, no? Decided to sleep instead. Your solution had like 12 layers. Even more for part 2, one for each direction, multiplied by how far it's gone in that direction, but all of those layers can be safely collapsed to just 2 because either you're changing direction or not. And if you are, you hop from vertical to horizontal. I'm trying to fix sleep so I can get back to normal time. Alright. Fix sleep by not sleeping, am I right? Because right now it's like deep night for you. That's how I fix my sleep schedule too. I just don't sleep. And then sleep the next day instead. It's not necessarily better. Well, it depends, yeah. Thanks to your effort, the Machine Parts Factory is one of the first factories up and running since the lava fall came back. However, to catch up with their large backlog of parts requests, the factory will also need a large supply of lava for a while. The elves have already started creating a large lagoon nearby for this purpose. However, they aren't sure the lagoon will be big enough. They have asked you to take a look at the dig plan. For example, this is our example. The digger starts in a 1 meter cube hole in the ground. They then dig the specified number of meters up, down, left, or right, clearing full 1 meter cubes. Is this Minecraft? The directions are given as seen from above, so if up were north, then right would be east, and so on. Each trench is also listed in the color that the edge of the trench should be painted as an RGB color code. When viewed from above, the above example dig plan would result in the following loop of trench and being dug out from otherwise ground level terrain. At this point, the trench should contain 38 cubic meters of lava. However, this is just the edge of the lagoon. The next step is to dig out the interior so that it is 1 meter deep as well. A lagoon can contain much more respectable 62 cubic meters of lava. While the interior is dug out, the edges are also painted according to the color codes in the dig plan. The elves are concerned the lagoon won't be large enough. How many? What about the color is completely unused, right? I'm assuming we're going to have a picture in the end. What's the RGB for here? So right now we just need to follow this, fill up the interior and So my question about the interior is, like, in the pipes, we could have like 2 pipes next to each other, and then the interior would be different. This example is not very good for me to understand the problem, I think. What is the interior in this problem? Depends on that thing. Let's save this. Day 18. input. Okay, well, I can just fill this up and then do a BFS from the edge, for example. And that's it. What if I add cargo add pathfinding? I'm going to try and use that crate instead here. Okay, so first we go around, right? So for line in input lines, we have what? Line split white space, and then direction is parts next wrap. I can match that. It's either left. Let me copy paste the direction. And the vex. Is Rust more like Python or C++? It's more like C++. Good for number crunching or UI or inputs. It's good for everything. Unlike those two languages. Alright. I'm sorry, I'm a hater of both Python and C++. I'm not sure which one of those is worse. Rust is just better. Hello there. Right. Down. Yeah, okay. Hold on. So right 6. Down 5. I'm an electrical engineer. Would it be useful to you? I have no idea what do electrical engineers need to do for their job. So I don't know. Sorry. I'm not an electrical engineer. I'm just a coder, programmer. What do electrical engineers do? I thought you do like soldering of the micro schemes. What do you need to do? What do you need the programming language for at all? To like calculate the things before you actually build the parts? I think it would be useful because Rust is just like you need to be more sure about what your code does, and that's like in general, Rust just helps you to not make bugs. Not all of them, but a lot more than both C++ and Python. Linux single board computer that controls other electrical stuff. Okay. So it's like Linux. So it's not even like is that even counted as embedded programming then? If you're running Linux? Electrical engineering program is for real-time application. So C++. So Rust instead. Okay, Rust is better. Just use Rust. It depends on like what platform are you doing it for though. But I heard people using Rust for it. It's just like, I don't know. When you use C++, you don't use any libraries? Or what? Maybe sometimes the Rust compiler cannot target the like the device, maybe, and C++ compiler can. But you say you're running Linux, so I don't know. Try reading up on Rust. You might not like it, then just don't. Or you might like it, then do. Lots of libraries for I2C and stuff. No, it doesn't matter what language you learn first. Yeah, you can learn both C, C++, Rust, Zig, I guess, I2C. I don't know what it is. Anyway. Oh, hold on. I think I know. We are going to like, this is going to be not 6, but like 6,000, 6 billion, or is it not? I don't know. And we are going to need to do it more optimally. Or maybe even in the current example. The color is unused completely. It's just almost a single digit. The biggest number that I see here is 11, 12. 11, I think, is the biggest number that I'm doing. Okay. All right, well, let me do this then. Let mute position is 0, 0, right? So over here, I say direction is direction to back, basically. And then I guess I don't need the direction then. Let me remove that. Just do back to -1, -1, 0, back to 1, 0, back to 0, -1, back to 0, 1. I'm followed because of Linux-based programmer. Going to play Escape from Tarkov because I have start responsibilities for a day. All right, good luck. Okay, so basically we have this, and then we have the number of turns, which is parse, next, unwrap, parse. So this is the number that I'm going to go there, and then the color is next, unwrap, strip prefix of the open bracket, and then strip suffix of the closing bracket, right? This is the color, but we're going to not use it anyway, right? So what we're going to do though is we go for this in 0 to number, position plus equal direction, and that's basically it. right? And then we like calculate the minimum and maximum position is what I want here, I think. Or let's just draw the map, sure. Sure, let's just draw the map. I will draw the map in the form of a hash set of vex. So like all the positions that we have been to, basically. So whenever I'm going somewhere, I'm just inserting the position again. And that's it. Right? Boom, boom, boom. Let's see. Minimum x is map we take the zeros, we take the minimum one. All right, so I want to take the minimum, maximum, minimum y, and then maximum x and y. Right. All right, let's try to use the pathfinding. Pathfinding. Undirected. Connected components. Components? Separate components of an undirected graph into a disjoint sets. Groups that have group of vertices connected together. No. Minimum spanning tree, I don't need that. I think I just going to do a BFS, right? Doesn't matter, directed, BFS, BFS, reach. I just need to find the reachables, right? Starts and successors. So start is going to be the minimum x and minimum y minus 1. Right? And this does what? What does this return me? EFS reachables. This is an iterator. Visit all nodes that are reachable from a start node. The node will be visited in BFS order, starting from the start. Examples. Okay, sure. So we do BFS reachable and successors. It's going to be for a position. For a position, I give out the connected things, right? So -1 0 1 1 0 0 -1 and 0 1, and then we filter map them. Delta position is position plus delta. If position 0 less than minimum x, turn none. just I drew the BFS from the outside of the map basically. Let me do -1 here and +1 here. Because I want to do one edge basically. Alright. So the last thing that I need to do is if map contains the position, and also return none. Right? Otherwise, some position. Closure my outlive, so I'm going to do the move here. What am I doing? I'm solving the advent of code, day 18. If you don't know what that is, it's a website which gives you the programming puzzles that you need to solve, basically. So what if I just do the count here? So this is unreachable, right? Unreachable is this. So the answer is actually max x minus minimum x plus 1 multiplied by max y minus minimum y plus 1 minus unreachable. Well, does Linux distros need activation? Of course. Did you not know that? Did you use an unactivated Linux? It was free like Ubuntu? 62 is the answer. Nice. It is actually correct. For the example, the first try, easy. All right. And then part 2 is the colors where we actually use them, right? Yeah, that's what I thought. This is like changing the numbers to be very big numbers. What I mean is someone realized what happened. Someone swapped the color instruction parameters when producing the dig plan. They don't have time to fix the bug. One of them asks if you can extract the correct instructions from the hexadecimal codes. Each this is 6 decimal digits long. The first 5 hex digits encodes the distance in meters. As a 5-digit, the first 5 is the distance, and the last is the direction. So now this is this many. I see. So we swapped out. What distro am I using? I'm using the NixOS. Swapped out. So first of all, we are just going to change the input, right? The input. So we have the color here. I guess the prefix that I'm going to strip is this. Together with the hashtag. All right. So I'm going to do if part 1 direction and number is going to be If part 1, then the original direction number. Otherwise, it's going to be something else. I'm going to parse the color, right? I'm going to parse the color. Standard string. Color. First 5. I32 from string. Color to 5. 16. So this is going to give me the actual number, and then the direction is the last one. The direction is basically match color 5. Is going to be either 0, 1, 2, 3, or 4. So like they said, 0 right, 1 down, right, down, left, up. Right, down, left, up. Down, left, up. Right, down, left, up. Okay. All right. So this only changes the way we parse the input, and if I try to do the part 2, then obviously it's going to run for too long. Wikipedia says NixOS is free and open source Linux distribution based on purely functional Linux package manager. Yeah, that's right. That's right. It's like Haskell, but their own language that we use to describe the system. Then why do you have the activate Linux thing? Because it's not activated. All right, you want me to activate it really quickly? It's like bothering you too much. All right, there you go. Now it's activated. All right. Now I need to think about how to do this problem though. Do you add it on purpose? Yeah, kind of. Kind of. Okay, so the question is though, can I still just iterate over all the positions? Because I think I can. I think I can. If I just say return here, will it still run? Well, it ran for a long time. What if I run it in release mode? If I run it in release mode, then it is pretty quick. What if I run it on the non-example? Then it is still running pretty slowly. So I don't think I can like iterate over all of them. I need to do something better. I need to do something better. Okay. So we can calculate whether we are inside or outside based on the number of intersections and things, right? Boop, boop, boop. Boom, 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 boom. Or what I can do is let me do this. Input lines map line. We're going to like just convert these into the commands, right? Of the direction and the number, right? And we're going to collect those into a vec. Commands is a vec of direction and the number of the ways. I'll do this I32 here instead, you know? I don't think it matters. I can do I64. Okay. So here's what we're going to do now. Position is 0, so I go for command for direction and number. In commands, I say position plus equal direction multiplied by number, right? So I need to be able to multiply by the number here. Output is self, multiply. This is done. So I just move in that direction. What I want to do is I want to basically store only the important parts, because then I can do it similarly like I did over here. Okay. Yeah, so I'm going to store the important coordinates. I'm going to compress my graph basically here. And then do the old solution still. So axis is hash set, and y is the hash set, and I say positions is back position, and over here I say positions. I mean, I can just do it here. Axis, insert position 0, and y's insert position 1. So just like that, I have all the different distinct x coordinates and all the different distinct y coordinates, basically, right? Right. Yeah. Then I want to like get compressed thing. Let me compress coordinates, which is going to be a hash set. And I'm going to return a vec of ranges, basically. Vec of ranges. That are important to me here. Okay. Chords. Let me collect those into a vec. Sort. Ranges. Something that I'm going to return here. I'm going to iterate over. So I'm going to basically, here's what I'm going to do. I'm going to, here's all the coordinates that I have been to, right? And I'm going to basically store all the ranges, including a singular one and the ones in between as like distinct things. And basically I'm going to compress all of that into just one thing instead. Right? Including the original one, which starts at the negative infinity, but instead of infinity, I'm going to use something else, maybe. So for basically chord in chords, right? I say that previous is going to be chords first one -1. So this is when where we ended previously. So I'm going to start at just one block before. I can just subtract whatever I want here. So over here I do ranges push. So from previous to this chord, right? And then I also ranges push this chord to chord +1, so that this is a single one, right? And then we say that the previous is going to be equal to chord +1. And then in the end, I'm going to say ranges push previous up to chords last unwrap +5, sure. Something like this. So this is going to be all the distinct ranges. So axis is compress the axis, and y's is compress the y's, okay? So this is going to be still the same, but I'm not going to just take the count. The only thing, I'm going to change the map here differently. right? I think I'm going to do something similar to this again. I'm going to start at 0, 0. I'm going to go over like that. And I'm going to say that so this is the next position, right? Position is next position. There is a solution that's linear to the number of lines in input string. Yeah, sure. But I don't think I need to do it like that. Wait, I mean, do I? Hold on. Why am I doing this? You are right. Hold on. This is so complex. I mean, I just can calculate the area, right? And that's all I need to do. I just need to calculate the area, which is very easy thing. We already used a formula like that in the previous Advent of Code, where we had the pipes. All right. Sure. Let me see. So I just add. I'm going right, for example. I add for it. I'm going left. I subtract. But hold on. I'm just used to this to do this on the non-integer grids. And this one is integer, which makes it a little trickier for me, I guess. But it's not very different, right? Shapeware is converting the coordinates that work with non-integer grid coordinate algorithms. Yeah. So like for the previous pipe, I used the theorem. I don't remember what was it. What was the pipe day? It was one of the first ones. This one. I used the pick theorem to do this. So when you are doing the integer, there is a formula to calculate the number of things inside. So like the area of this polygon is the number of things inside plus the number of integer coordinates on the boundaries divided by 2 minus 1. So we know the area. We know the area. And I can calculate the boundary. So I can take the inside, and then I take the inside plus the boundary as the number of integer instead. Right? Sure, I can do this. This is much simpler. I already did it. Yeah, I'm too lazy to finish this, I guess. Although I think this would also work. It's just like so much more complex here, right? So I just do this. For this in commands, I calculate my current position. I don't even need my current position. I don't even need my current position, right? I just multiply direction x, basically. Multiply this by the number. And this is added to the area. And then I add to the boundary the number, right? Just like that. So then the inside is going to be equal to area plus 1 minus boundary divided by 2. Area plus 1 minus boundary divided by 2. Assert that boundary is divisible by 2. Alright. And then we just do the answer is boundary plus inside. Yeah, this is much easier. Just 5 lines of code. Compress. Okay, fine. I delete this. I delete all of that. Hold on. This is all wrong now. This is all wrong now. Hold on. I need to take the absolute value of the area. Maybe that's the reason? No. Inside is negative. Well, area is equal to 0. I see. Wait, I see it. Position. Position plus equal direction. Divided by number. I need to add to the area the current, current position y. Okay. 62 was the answer in the first one, right? Yeah, 62 is in the first one. And then we do part 2. For the part 2, for the first one, is still the wrong. Is it still wrong? For the part 2 example, hold on, example first. Example is 952115. Okay, it looks correct. Okay. But this means that this problem is exactly similar to the other one. Why did they do two things that are like almost exactly correct? Almost exactly the same. Day 10 and day 18 are literally the same. Well, I guess only the optimal solution like this is the same. All right then. Maybe I should have still finished the one that I was doing, because it would be more fun. But now I'm too lazy to do that. Now we are done with this. Now I can commit this day 18. And yeah, that's it. 4 hours is all that was needed for us to do. What was the first day that I started with today? 14 to 18. I did 5 days in 4 hours. Easy. All right. See you next time, I guess. That's going to be it for me for today. My head is starting to hurt a little bit. So I will go and take a rest now. Who's streaming? Who is doing Advent of Code? Advent of Code. Well, I guess Captain Coder. Let's go there.
We're gonna come through here. All right, let's exit out. We gotta stay on the treadmill till we get all the way done. All right. Woo.
But he's playing the game.
I'm exhausted. Heart rate's at only 80. Come on.
Well, maybe he's doing it in the
My watch, you're lying. What is my heart rate really at? 105.
in the meantime. All right.
Bad.
Let's see what's happening there. Bye. See you next time.
Going for almost 2 hours here. We're gonna take a quick break. AOA. Did someone give AOA a shout out? Let's give a shout out here. Whoa. At Score, I know AOA. Thank you so much